Welcome to September 5th LeetCode Challenge, Orderly Queue. You're given a string S and an integer k. You can choose one of the following first k letters of S and append it to the end of the string. Return the lexicographically smallest string you could have after applying the mentioned step in any number of moves. So we're given a string CBA here, and we're given k, integer k of 1. So basically we want to, and we're given this output here, we want to basically, in the first move, we move the first character C, right, to the end of, I'm just going to copy that actually. Move the first character C to the end of the letter, so it becomes C, BAC. And then the second move, we take the first character, B, and we move it to the back as well, so B becomes B, A, C, B, right? And that's a character we get out. So that's the lexicographically smallest string you can make after applying basically the one character move in each one character in S at any numbers of steps. Right, because we have don't have a restriction on the number of times we could do this. Likewise, we have this character here, BAACA, and we want to basically move 3 characters at a time, first 3 K characters, and then we want to basically have this output. So how do we do that? So the first one is we can move character we can move character B to the N, which becomes AACAB. And then lastly, you can move the third character, which is basically C, to the N as well. So it becomes AAABC. Right? And that's pretty much it. So we can move basically K characters, which means it's any character from the beginning of the string, first characters, I should say, and move it to the end until it becomes the smallest lexicographically string you can make. So that's pretty much it. To solve this, we just use a little bit of a math equation here, or some understanding, I should say, of math and how do we make the lexicographically smallest. So obviously, lexicographically smallest means that it's basically starts with ideally A, B, C, D, and all in that order, sorted out. Moving basically the first first number of K characters possible, right? We can't make, for instance, A, B, C from this because A is always the first character, and if we move it to the very end, we'll have C, B, A, and we'll just keep on cycling through as well. So we can't make it any smaller than it is already. So if K is, I'll just kind of word it out here. So we know if K is greater than 1, then we can change any 2 adjacent elements. First, we can rotate our string such that we have, for instance, if we have A, B, X, right, or X is some string, so that's the case where K is greater than 2, then we could put B at the end of we put B at the end and A to the end as well, and then we can rotate again to have basically BAX, right? We could do that. That makes it possible, right, mathematically. So we can also look at this as kind of like a bubble sort type of approach where doing these moves of sorting. So however, if K is equal to, I'm just gonna write that out. So in terms of the bubble sort, so basically we're gonna return the string, we're gonna join it with sort S. So that's what we want to do, right? If K is greater than 1. Else, if K is equal to 1, then we're allowed to rotate the string, and our goal is to choose the smallest one amongst the n options. So I mean, if K is equal to 1, essentially you can move any single letter all the time, just like for the example right here. Keep on moving it, rotating it until we find the smallest one, right? Because we can't move any other characters. So basically, if k is greater than 1, we just sort this character out, and then we choose it, and we just basically join it together using anything greater than k to make it small, right? Sorted. So it keeps on running this loop. So I'm gonna make a visit set to keep track of letters of basically cycles, different permutations of strings of that we've already checked, right? And we're just looking for the smallest one or the minimum. So while s not in visited, what we're going to do is that we are going to visited.add of s. Then we want to update s to be the slice between k to the end of the string plus s of slice of from the end of k to there. And then we want to return the minimum within our visit set. So this is basically a brute force type approach. Let's run the code. Finished. Submit it. See if this works. Alright, there you go, accepted. So time complexity is big O of n squared because we have a while loop here, which is n times. And then we have a min function here, which is also n times. So it would be a total big O of n squared. And space complexity is big O of n because we store everything in the visit set. Alright. Yeah, so that's the code. Let's make it this a little bit nicer or a little bit better looking. So instead of having a visit set, let's just see what we could do to make this a little nicer. Actually, let's compress all this into one line. So we can actually do this, return the min. We can, instead of doing a while loop, so we're just going to do s at I for k in range length of s. Let's see if this works. I'm not sure what k is really the best value to use. And I'm just gonna Dominique Allstate there either. Just put it right there. Hopefully this works. Six. Oh, well, line 6. Oh. Duh. Let's submit this, see if this works. Awesome. So we just compressed that to basically instead of a while loop to using a for loop as well. Let's see if we can make this even better. Let's see. Let's see. If k equals 1, else. There you go. Let's erase this line. Oh, accepted. There you go. Just basically compress all that we had before into one line. So yeah, this is I make it look easy, but at the same time, the little bit of thinking, it's a bit of recognizing the mathematical pattern behind switching and recognizing that it's similar to the bubble sort type algorithm as well. There's another algorithm called boost algorithm as well, which is very similar to, it has the same idea approach to it, but the constraints are a little bit different. But there you go. Have a great day, guys.